Okay, so in this video, I'm doing an introduction to factoring, starting with GCF. GCF stands for greatest common factor. And it's going to be the basis of factoring because essentially we're just constantly taking out the greatest common factor between all the terms in a polynomial. So first, I just kind of do a quick overview of examples of GCF. So for example, if I ask to find the GCF of 20 and 30, to find that, it's helpful to look at or to list out all the factors of both numbers. So the factors of 20 are 1, 2, 4, 5, 10, and 20 itself. And for 30, it's 1, 2, 3, 4, oh no, not 4, 5, 6, 10, 15, and 30. So now we're going to go down the list and see what is the highest number or the greatest factor that they share. In this case, I notice it's 10. So my GCF here is 10. And you'll see how this is going to play out in factoring, because that's essentially what we do is we just find the GCF of the terms of a polynomial. So let's just do a few more examples here. So if we were to do GCF of 30 and 77, well, for 30, like what you listed before, it's just going to be these. Now 77 is interesting because it's a prime number, so I just have 1 and 77. So in this case, the GCF is actually just 1 because that's the only factor that they share. So sometimes that might be the case where they don't share anything. So that's something to be mindful about. Okay, so let's do maybe a couple more of these. But these are pretty straightforward. Just finding GCF. So for 7, again, that's a prime number, so I just have 1 and 7. For 21, that's 1, 3, 7, and 21 itself. And as we can see, we have a GCF of 7. Okay, and let's try maybe 40 and 100. So for 40, I have 1, 2, 4, 5, 8, 10, 20, and 40 itself. All right, so, and then for 100, so 1, 2, 4, 5, 10, 50, or no, sorry. Or, no, is that right? No, there's more stuff in between. So 20, 25, 50, and then 100. So going through this list, I see that my GCF is 20. So I'll write that here. All right. So now let's actually get on to, real factoring. Actually, okay, no, before I get into it, I'm sorry. I wanted to talk about what if I had just variables. So GCF of x squared and x to the 5th. So this is interesting because, these aren't numbers, right? So they don't really have like actual factors, I would say. But for x squared, we can maybe break it apart and notice that's, okay, x times x, right? Likewise, x to the 5th, that's x times x times x times x times x. So this is sort of the matter of how many x's do they both share. In this case, they only share 2, right? So the GCF between these two are x squared. And that's usually the case. It's usually the smallest, actually no, it is the smallest power x that you take out of, right? So if I had to do GCF of x cubed and let's say x to the fourth, right away I can just say, oh, my GCF is x cubed because that's my smallest one. And again, if we wrote this out, x cubed is x times x times x. X to the fourth is x times x times x times x. We can only take out a maximum of 3 x's out of both of them. So that's something to be mindful about and something that we'll see when we do factoring. All right, so let's see. Let's try to find okay. Find GCF of 15x to the fifth, negative 12x to the fourth, 27x cubed, and negative 3x squared. Okay, so I would first look at the coefficients. I feel like that's much easier to work with first. So looking at all these numbers, I have to figure out, okay, what is the largest number that they all share? In this case, it's actually going to be 3. So curious if I want to do negative 3 or, no, yeah, let's just do negative 3. So I'm going to take out negative 3. And then for my x's, so again, I choose the smallest amount of x's I can take out. So, or sorry, I said that backwards. I choose the largest amount of x's I can take out of each one. In this case, that's going to be my x squared. So my GCF is just negative 3x squared. Okay, perhaps let's do another one. Okay, so here, again, it's easier to just kind of do it piece by piece. So I'm just going to look at the coefficients first, which are these numbers here. And I look at, okay, what number can I, or what's the highest number that they share? In this case, it's 2. And then for p, so I just choose the smallest p that I can take out. In that case, it's just going to be 1, right? Just a regular 1p or p to the 1. Now, what about my y's? Well, if you notice, the 4p cubed doesn't have a y. So in this case, I can't even take out a y because not all of them have it. So I can just stop here with just 2p. Okay, let's do a couple more like this one. And again, I'm trying to find the GCF. So the GCF here. So looking at 12 and negative 16, I can take out the highest number that they could share is 4. And for the x's, again, I'm choosing the smallest power. So I just have x squared. And then let's do another one here. So this one, for the coefficients, if you notice, I can't really take, or there isn't any number that they all share. So in this case, I don't need to take a number. So I'll just move on to the y's. And again, I just pay attention to the smallest here. So my GCF is y squared. Okay. And I think this next one will be my last one. Okay, so again, I start off by looking at the coefficients here, negative 24, 12, negative 16, and 8. So the highest number that they would all share is, I believe, just 4. And you could do negative or positive 4. I honestly don't think it would matter too much. But and then for the m's, again, I pay attention to the smallest power. So in this case, that's just this regular m. So I just have 4m. Same thing for n. I look at the smallest power for n. In that case, it's n squared. So that's my GCF there. And really what we've been doing here is it is pretty much factoring, but it's, I guess, just half of what we have to do. Okay, so so now with like regular factoring, I'll kind of do like a very generic form. If I had AB plus AC, when I factor, I notice I can take out an A out of both of these. So the A goes on the outside, and on the inside I have a B plus C. And then likewise, if I had AB minus AC, this is the same thing as A on the outside and then B minus C. So what we're going to start doing is we need to figure out, what goes in the parentheses. And so we'll do some examples here. So we need to factor 7x squared minus 14, or sorry, plus 14. So I look at, okay, what do both 7x squared and 14 share? In this case, it's 7, so I can take out a 7 here. Now, I look at, okay, what do I multiply 7x squared by? Or sorry, what do I multiply 7 by to get to 7x squared? In this case, it's x squared plus, and then 14, 7 to get to 14, that's 2, right? There's a few ways you can look at this. Is you could maybe say, 7x squared divided by 7 gives me x squared, and 14 divided by 7 gives me 2. You could do it that way. Or maybe you could rewrite this and say, 7 times x squared plus 7 times 2. But, I think it's just, either way, you're thinking about what's the leftovers, basically. After I take out 7, what do I have left after I take that out? It's the same idea as up here, right? I took out an A, but what's left? I still have a B, and I still have a C. So same thing here. I still have an x squared, so I need to put that there. And I have a 2 left over from when I took out the 7 from 14. And remember, we're dealing with a multiplication, division kind of thing. We're not doing like addition or subtraction. Okay. So let's do another example here. So this is my answer for when I factor that. Okay, so here I need to look at, okay, what can I take out, or what do 16 and 20 share? And I believe the highest one is just 4. Oh, my bad, not done yet. Okay, so that's the number. And then for my variable, if you remember, I choose the smallest, or yeah, I take the smallest power here, so I have x squared. I don't know why I wrote that there. Okay, and then parentheses. So, okay, like what do I multiply 4 by to get the 16? It's just 4. Or you could think of it, honestly, probably just 16 divided by 4. That might be an easier way to view it. Yeah, so 16 divided by 4 is just 4. I took out 2 x's from the x cubed, so I just have 1 x left. And then plus 20 divided by 4 is 5. I took out 2 x's from the x squared, so I'm just left with plus 5 there because I already took out all those x's. So this is my answer for this one. So let's do something a little bit more involved, I guess. Okay, so I have this polynomial here. And again, I'm paying attention to my coefficients. And I can take out a 3. Now looking at my x's, the lowest one is x squared, so I'll take that out. And now in here, so 15 divided by 3 is 5. I took out 2 x's from the x to the 5th, so I just have 3 x's left, so x cubed. Maybe I shouldn't say 3x, that might sound like 3x, but what I mean by that is that there's like x to the cubed. 12 divided by 3 is just 4. I took out 2 x's here, so I have x squared left over from the 4. And honestly, you can actually just see this as just like subtracting the exponents, right? Because that's essentially what we're doing with these. So I'm just subtracting the exponents and writing the like what's left. 27 divided by 3 is 9. 3 minus 2, I have x. Negative 3 divided by 3 is minus 1. Actually, I don't even need to write 1 there. I can just put just simply minus. Or no, I can write 1. That's okay. And, I took out x squared from x squared, or like 2 minus 2, so that's just 0. So I'm just left with minus 1 at the end. So this is my answer. Perhaps for some of these, like maybe I could go further, but I'm just going to wait on that for a bit until we get there. So this is just kind of starting small, working our way up. So let's do some more examples. Okay, so here, again, I pay attention to the number, or like the coefficient, and the highest number I can take out is 12. Now for the variable, if you notice, the minus 36 term here, the last one, doesn't have an x. So in this case, all I can take out is a 12. So I can just go straight in and just say, okay, so 24 divided by 12, that's 2. I didn't take out any x's, so the x squared sticks around. Plus 12 divided by 12 is just 1, and I'm just left with an x. And then minus 36 divided by, or negative 36 divided by 12 is just negative 3. Okay. So let's maybe do 2 more. Okay, so here I can take out an 8 out of both of these. For the m, I just choose the smallest, so that's just m to the 1. 8 divided by 8 is just 1, and 3 minus 1 is just m squared, minus 16 divided by 8 is 2, and I already took out 1m, so I just have 2 there. Okay, I think this will be the last one for this type of factoring. So again, looking at the coefficients, I can take out a2. For the p, the lowest one is just a p. For the y, I can just take out just one y. Here, so 14 divided by 2 is 7. 2 minus 1 is just p. There's just p1. 3 minus 1, so I just get y squared. Minus 8 divided by 2 is 4. I took out a p, so no need to put that there. 2 minus 1 is just 1p, or sorry, 1y. I took out a 2 divided by 2 is just 1, so I didn't need to write much there. Actually, yeah, so like pretty much all this is taken out, so I just have a plus 1. And I should probably explain why I'm putting plus 1 is it's because like really you can see it as like 2py divided by 2py, and that's just 1, right? And if you think about it, if I multiply this out, I multiply 2py times 1, I will get 2py at the end. So that's kind of the idea here. It's sort of like I'm reversing the whole multiplication process. So that's why it's plus 1 there, because that's how I'm able to get 2py from the original. Okay, so I think this is the last thing that I'll talk about, and this is factor by grouping. All right, so I guess kind of starting small here. X squared times x plus 1 plus 2 times x plus 1. So the idea is I can take what they share, which is the x plus 1. Like, so if you notice at these two terms, they have something that they have in common. In this case, that's the x plus 1, so I'm just going to take that out. And then what I have left over is the x squared and the plus 2. So I'm going to write x squared plus 2. So I always write first because it's a little bit easier for me to remember is like I take what they share, write that first, and then I write what's left, like on the outside. So if I had, and then this is my answer here. So if I had x squared, x plus 7 plus 3 times x plus 7. So these are my outside pieces, and they share x plus 7. So I write that first. And then I write my outside pieces together, so x squared plus 3. And that's my, that's how I'll factor that. But fortunately, that might not always be the case of how we're presented a factoring problem, right? More than likely, or actually very likely, it will be given to you this way. 6x cubed minus 9x squared plus 4x minus 1. I should note that this only works with 4 terms. So anytime you see 4 terms, more than likely you're gonna have to do factor by grouping. I hope I wrote that there. Yeah, factor by grouping. So this only works with 4 terms. So just kind of keep that in mind that this is not going to work for like 3 terms or 5 terms, that kind of thing. So just kind of be mindful about that. So, so here we might need to do just an extra step, and that's okay, because it's nothing too like new or outside of what we've been doing. So to factor by grouping, you take the first 2 terms and you just factor this. So, okay, I'm going to look at, okay, what do 6 and 9 share? Okay, they share 3. Now looking at my x's, what can I take out? I can take out a x squared. So 6 divided by 3 is 2. And I took out x squared from x cubed, so I just get an x minus 9 divided by 3, which is 3. And I took out an x squared from both of these, so I just have the negative 3. Plus, so again, I'm looking at, okay, what do 4x and 6 share? In this case, I share 2, so I'll take that out. 4 divided by 2 is 2. I didn't take out an x, so the x sticks around. Minus 6 divided by 2 is just 3. And you know you did this right because you see that you have the same thing in the parentheses. That's exactly what we want. If you get something different, that means something might have went wrong. So just make sure that these two end up being the same. So I'll write that first, so 2x minus 3, and then 3x squared plus 2. So that's my answer here. Okay, let's do a few other examples. All right, so again, factor by grouping. So I'll first look at these two. Again, I choose the smallest one, like the smallest power to take out. So the x squared goes out here. Think of it as like 3 minus 2, so I just have an x. And then, you know, I guess if you do 2 minus 2, you just get x to the 0, which is just 1. And I'll write that note here. X to 0 is just 1. And then here, so the only thing I can really take out is technically 1. You don't have to write 1, but I'll just do it anyways. And I'm just left with like x plus 1. And that's okay if this happens, like that's totally fine. But just kind of be mindful that there is technically a 1 outside of the parentheses, and you can just rewrite that. So if you notice, again, I have the same thing in the parentheses, so I'll write that first, x plus 1, and then combine my outside pieces, which is x squared plus 1. Okay, I think I'll do maybe one more example like this. Okay, so here I'll factor the first 2 terms. 2, negative 6, I can take out a 2. For the x's, I can take out an x squared, so I'm left with x on the inside minus 3, right? Because so with the x's, I took out 2 x's, so I just have 1 left over. And then I took out all the x's for the second one, so I just have 3, because 6 divided by 2 is 3. Here, I think what I can do is just take out a negative 1. And then here I'll have x and then negative 3, because 3 divided by negative 1 is negative 3. And the reason why I took out the negative 1 instead of just saying plus 1 is because I recognize that if I didn't do that, I would be left with x plus 3, and that doesn't match the other one. So I wanted to make sure that they matched. So I'm gonna put x minus 3 first, and then 2x squared minus 1. Okay. So that's how you factor by grouping.